guys, welcome back to In Case of Econ Struggles. Today I'm going to start talking about MLE or maximum likelihood estimation in Stata. This is going to be part one of a series where I'll do some other stuff about MLE as well. So if there's specific parts of an MLE command that you want to see, make sure to put that in the comments below. But today what I'm going to do is just show you how we can replicate a OLS model using the maximum likelihood estimator in Stata. I'm not going to show any constraints. Part two I'll show constraints. But today it'll just be trying to replicate this OLS regression where I'm going to use the auto data and I'm going to regress price on miles per gallon and weight. So what we can see is we've got our usual output and we're just going to show that I can use MLE to get something that's extremely close, maybe not exact, but extremely close to these coefficients. So that's what we're going to do. The first thing we got to do is we have to define our maximum likelihood program in Stata. And so that's going to be with a program defined command. So what I'm first going to do is I'm going to cap, just so if I don't have this program, it's going to make sure that I drop it and not throw me an error. And I'm going to call this program or this maximum likelihood sort of routine MLE_demo. Now the first thing I need to do is I need to tell Stata what the arguments are in this maximum likelihood estimation. So this is going to be my log function, my log linear function right here, which I'm going to call LNF. XB is a special case in Stata. This is going to be the predicted value from my linear fit. And this is going to be what I'm going to call my sigma or the standard error of my regression. Now what I'm going to do is I'm going to generate some temporary variables to help me. And so those are going to be tempvars, which are going to be my epsilon and my sigma squared or sig2. So the first tempvar or E is going to be the residual in my regression. That's going to be my actual dependent variable or maximum likelihood underscore Y1. Y1 because you could have several dependent variables if you're doing like simultaneous estimation. But this is going to be my dependent variable minus my predicted value, which of course is what we know is just the residual. And then the variance of my regression is just going to be this v squared. Now what I'm going to do is I'm going to set up a log likelihood function, which is just based on a normal distribution, which is an assumption that I'm making in this model. But of course, that's generally a good assumption. And so this is what the log likelihood function looks like for a normal distribution, where it's just negative 0.5 times the natural log of pi minus natural log of my variance. And this is going to be my residual. Now, the reason I have minus signs here is because I'm going to do a maximization rather than a minimization. If you want to do a minimization, you could make these positive and that would be the same. And that would work the same way. Okay, so now let's just work all the way through this code just to make sure we got it set up. And now what we can do is we can do a couple things to test that our maximum likelihood procedure is going to work before we actually try it out. So the first thing I'm going to do is I'm just going to initialize this maximum likelihood estimation. So I'm going to tell Stata this is the model I'm using. This is my dependent variable. These are my independent variables. This is a free parameter v that I want it to estimate, but I'm not going to tell it any sort of starting value. And now what I can do is I can tell Stata, hey, make sure this is going to work. Do a check on this guy and tell me if you see any error or not. And so what it's going to do is it's going to do a bunch of different tests. And it's going to make sure that basically it can initialize properly. It can do a little bit of tweaking, not all the way. Is it going to make sure that everything sort of works before we try and actually run it on our data? And it looks like it has. It's passed all tests. And this last one here of unanticipated output, that's generally fine because I'm doing tempvars. If I say didn't want this ML201 to come out of here, maybe I want to make sure I quietly do that. I'm not that worried about it. I'm going to let that stay in there. And so that means that I'm sort of ready to go. And so what I'm going to do is I am going to comment out this ML check. And then let's go ahead and maximize. And we're going to see that it goes through. And we have our coefficients here. And just for comparison, let's put our OLS back in. And you can see that these coefficients are they're not exactly the same as what we had before, but they're pretty darn close, both in the coefficient and the standard error. I only have 74 observations, so it's not surprising that they're not exactly the same. But qualitatively, those are really, really close. And I have this MSE, or basically our standard error of the regression, which should be very similar to root MSE. And it is, so everything looks well and good. And I would say that this is generally a success. So I'll put this code in the comments below if you would like to see it. Again, if there's a specific part of MLE estimation that you would like to see me do in one of these videos, please put that in the comment section below. But if this video or these videos in general are helping you out, please like and subscribe. See you next time for another case of econ struggles.